Hello, and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of writing exponential functions. This is standard A.9C in the great state of Texas, and we are using item number 35 off the 2017 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have the amount of fertilizer in this landscape company's warehouse. It's decreasing. We got a 3% rate decrease. The amount of fertilizer in the warehouse was originally 78,000. So we need a function that models the amount of fertilizer in cubic yards that left after W weeks. So hopefully we see from not only the word problem itself, but from our answer selections, we are dealing with an exponential function. So what does that look like? Well, the standard form is going to look like this. Y equals A times B to the x power. And each of these terms is going to do something different for us. So this A is going to be multiple things depending on the context. So if we're dealing with money and compound interest, it's the principal. It's the starting amount. So if you wanted to view it as the starting amount or starting place, it's the initial amount. And if we had a graph, we could also call this our y-intercept. Now, why could we call it our y-intercept? Well, remember when you're graphing something, right, the y-intercept is where it crosses that y-axis when x equals 0. We'll take a look at our original equation up there. What happens when we make that exponent 0? Well, that would be b to the 0, which anything to the 0 is just 1, which takes that whole thing out of there and just leaves us with a. So 3 different ways to look at a. It is our starting amount. B here is going to be our rate. Now, depending on the context, it's either going to be a growth rate or it's going to be a decay rate, whether it's increasing or decreasing. And then your x is going to be your steps. Typically, it's going to be some type of time frame. And so we've got weeks here. Could be days. In bacterial growth, could be years. If we're dealing with compound interest, it's some type of step there. So let's see if we can take that information and build the correct representation. So we're going to say f of w equals, that's going to represent the y, a, our principal, our starting amount, our y-intercept. Well, they give it to you right here. They always have to give it to you unless there's a graph. It was originally 78,000. Okay, so that's your starting amount. Now, the growth rate or decay rate, in this case, it's decreasing, so that lets us know it's a decay rate. That's a little bit tricky because what we don't want, and it's, as you notice, there's not even a 0.03. It's not even an option right here. So when we're dealing with it in this context, we don't just write 0.03. And the reason I say 0.03 because we need to take our 3%, right, and we need to turn that into a decimal. So we're going to move the decimal over once, twice to the left. We get 0.03. All right, so we deal with it as a decimal. But the reason why we don't just simply put that 0.03 in there is because that would just give us the percent or the amount decreasing, but it would not give us a total. So the total amount is going to be one whole, right? 100% of that 78,000. It's decreasing at 0.03 each time. So what we actually need to do is we need to subtract that 0.03 from that 1. So basically, each time it's iterating, we're getting 97 hundredths of it remaining. So anything less than 1 is going to be a decay rate, which is what we're doing. Anything greater than 1 is going to be a growth rate. So that's why you've got these two right here. That 1.03 is if it were a growth rate, but it's not. It's a decay rate. And then we're going to do it like that with the W. So here's our answer, C.